Okay, so this is the third and final installment of our videos on forces, and I want to do another example that will involve friction, but now I want to look at what's called an Atwood's machine. Okay, and so what it is you have a mass. Let's call this M1, and it's connected to a pulley, and it has another mass attached to it, and we'll call this M2. Now, the forces that are acting on these two blocks, M1 has got its force due to gravity, and it's also got a tension force. Now M2 has its mass due to gravity, and it also has a tension force. Now, let's say in this example, M1 is accelerating up at, let's just go 2 meters per second squared. And let's say M1 weighs 6 kilograms and M2 weighs what? We don't know. Okay. Well, what we can do is this block is accelerating upwards in the y direction. So I can go, okay, the summation of my y forces needs to equal my mass times acceleration. Well, I know my acceleration and I know my mass for that one. Okay, so what I can figure out from there is what is the net force being applied to that block. Well, the net force is going to be your tension minus your force due to gravity. Well, what I can do is I can solve for my tension force here. So if I've got my mass is 6 times 2 gives me 12 equals my tension minus my force due to gravity is going to be mg. And a lot of the problems on the free response, you can assume g is 10. So 6 times 10 gives me 60. I add 60 to both sides. I get a tension force of 72 newtons. That tension force is equal to this tension force. Okay? Now, if this block is accelerating up at 2 meters per second squared, that means that this block needs to be accelerating down at 2 meters per second squared. Okay? So, over here, I can go, okay, the sum of my forces in the y direction. Well, now I've got my mass times acceleration. And so I've got mass times, here it's going to be negative 2 meters per second squared. And that is going to equal, again, my tension force minus mg. Well, over here I now have negative 12 equals my tension force minus mg. And I don't know my mass, but what I do know is that my tension equals 72 newtons. So I can subtract 72 newtons from both sides, and so I get, on the left side, I get negative 84 newtons equals minus mg. So what I can do is divide by negative g, and I would get, if I'm assuming that g is 10, I would get my mass of the other block to be 8.4 kilograms. Which makes sense, because if I release these two blocks, this one needs to be heavier in order to pull the M1 up. Okay, so that is an Atwood's machine. Now, this is how our elevators work. In an elevator, you've got your car. And this car is going to be in between two walls. Okay? And again, it's going to be connected to a cable. And then that cable is going to be connected to a counterweight. Now, the reason we have this counterweight is because it eases the work that needs to be done by the motor. This counterweight helps pull the elevator up, and it helps pull the elevator down. Now, let's say that now my car is in between two walls. So I've got my force due to gravity, but now let's say the elevator is going up. Well, now I've got a force due to friction also trying to pull the elevator down. Let's assume that the elevator is moving, so it's going to be kinetic friction. Okay? And then last force that I have is this tension force. Now, let's say that the elevator and me both weigh, let's say 450 kilograms. Okay, that's my mass. And I don't yet know the mass of my counterweight yet. So, this would be your free body diagram for the elevator. You'd have your friction forces, your gravity force, and your tension force. So now, let's say that each sidebar hits the elevator with a force of 50 newtons, each one. So that means that my combined force due to friction is going to be 2 times that. So the summation of my forces for my elevator is going to be, it's going to be in the y direction, is going to be my tension force minus my force due to gravity, but also minus 2 times my force due to friction. Okay? Now, let's say that this elevator is accelerating up at, let's go again with 2 meters per second. So, the summation of my forces in the y direction, summation of forces equals mass times acceleration. So now, I can figure out what my tension force is. So, tension minus the force due to gravity is going to be mg. And 2 times my friction force is going to be 100 newtons. That equals my mass, which is 450, times my acceleration, which is 2. So, solving for tension, I'm going to add 100 newtons to the other side. So I've got 450 times 2, which is going to give us 900. Then I go plus 100, or plus 100. And then I'm also going to add the mass times gravity. And let's again keep it going with just plus 1,000, plus 100. Let's again keep g at 10. And so add 100 to both sides, you get 1,000. And now I'm going to add my mass times gravity, which is going to be 450 times 10. So that gives me a total tension force of 5,500 newtons. Okay? Now, again, if I wanted to figure out the mass that this counterweight needs to have, free body diagram, the forces acting on it are its force due to gravity, and also this tension force. Well, now I know the tension force is 5,500 newtons. Now, this counterweight is going to be accelerating down at 2 meters per second squared. So again, do the same thing as we did before. The summation of my forces in the y direction for my counterweight is going to be m1 times my acceleration, which is -2. And that's going to equal tension minus the force due to gravity, which is m1 times g. I know my tension, I know g, I need to solve for m1. So I can add this to the other side and get -2m1 minus m1g equals t. So I factor out an m1, and I get -2 minus g equals my tension force. And so I can divide that. So I got m1 equals tension over -2 minus g. And, oh, whoops, I should have added. So that becomes -2 plus g. Whoops. Got to add that to both sides. And so I've got tension, which is 5,500, divided by -2 plus g, which is 10. And so I get a mass of my counterweight, which would be 680, let's go 688 newtons. And that right there is a little insight of how our elevator system works.